Lesson 9.5, Solving Quadratic Equations by Using the Quadratic Formula. Our essential question is, how do you use the quadratic formula to solve a quadratic equation? We have one vocabulary today, and that, of course, is the quadratic formula. To use the quadratic formula, your quadratic has to be written in standard form. So remember, standard form looks like this. Y equals ax squared plus bx plus c. It could also have f of x in place of y squared. It could also have no y or f of x and just have your quadratic set equal to 0. So any of those situations you would be able to solve using the quadratic formula. The key is that you really need all of your terms on one side, and you need to have a 0 on the other side of the quadratic. Okay, solve using the quadratic formula, round to the nearest tenth. The first thing I need to do is I need to write all of these terms on one side of my quadratic. I happen to like a being positive over here, so I'm going to leave that 2x squared, and I'm going to subtract the 12x and add the 13, like that. Now, my quadratic formula says x equals the opposite of b. Well, I have a equal to 2, b equal to negative 12, c equal to 13. So the opposite of negative 12 is positive 12. So 12 plus or minus the square root, and now we have the discriminant part, b squared minus 4 times a times c. Okay. And it's all divided by 2 times a. Make sure that you don't forget about the bottom of your fraction. That's a pretty common mistake that we see. Now, the simplifying part. I am going to simplify the denominator. 2 times 2 is 4, and then the discriminant. Negative 12 squared is positive 144. Then I'm going to multiply all 3 of these together. So negative 4 times 2 times 13 is negative 104. Right there. Okay. Now, underneath the root, I can simplify that. 144 minus 104 is 40. And then the square root of 40 is 6.32. So this part right here is 6.32. I am going to round my final answer to the nearest tenth. I'm not rounding it to the nearest tenth yet because I want to not be that specific until the end of the problem. Now I need to split to get my 2 solutions. So 12 plus 6.32 divided by 4, and 12 minus 6.32 divided by 4. So my first one is 18.32 divided by 4. So if I divide that, I get approximately 4.6. The second one is not going to be negative 4.6. 12 minus 6.32 is 5.68. If I divide that by 4, x is approximately 1.4. So it's very important for you to solve for both solutions. Don't solve for one of them and then just make it the opposite sign on the other one, because these are 2 completely different values. So this quadratic, if it was graphed, would cross the x-axis twice. It has 2 solutions. approximately 4.6 and approximately 1.4. Okay, our next quadratic, I am going to rewrite to standard form again. So I'm going to move the -9 over and make it positive. So on this one, A equals 1, B equals -6, and C equals 9. So x equals the opposite of b. The opposite of -6 is +6, plus or minus the square root of our discriminant, -6 squared minus 4 times 1 times 9. All divided by 2 times a, and a is 1. So simplifying the denominator, I get 2. The discriminant, -6 squared, is 36. And then multiply all 3 of these together, and you get -36. Well, 36 minus 36 is 0. So x equals 6 plus or minus the square root of 0 divided by 2. Well, the square root of 0 is 0. So it really is not going to matter. And I'll show you. It's not going to matter if we split this to try to get 2 solutions. One of them is going to have 6 plus 0 divided by 2. The other one has 6 minus 0 divided by 2. Well, 6 plus 0 is 6. 6 divided by 2. 6 minus 0 is also 6. So there is only one solution on this problem. X is equal to 3. So when the discriminant equals 0, we said there would be one solution, not 2. And this is why. Because the square root of 0 is 0. There's no positive 0 and negative 0 that would make a difference here. So when the discriminant is a positive number, we have 2 solutions. When the discriminant is 0, we only have one solution. We only have one solution. So that means that the vertex would be touching the axis. So the quadratic doesn't cross through the axis, it just touches at the vertex. Okay, our third example, on this one, you may notice something different. It is written in standard form. Ax squared, so a is 1. There is no term with a plain x, so that means that b is 0 and c is 6. So when we plug this one in our quadratic formula, the opposite of b, well, the opposite of 0 is 0, plus or minus the square root of 0 squared minus 4 times a times c, all divided by 2 times a. Okay, so 0 plus or minus, my denominator would be 2. Look at the discriminant. 0 squared is 0, and if I multiply all of these together, I get -24. 0 minus 24 is -24. So 0 plus or minus the square root of -24 divided by 2. If you try to solve the square root of a negative number on a calculator, it gives you an error message. You cannot multiply a number by itself and get a negative result. A positive times a positive is a positive. A negative times a negative is a negative. So there is not a square root of a negative number. So we say no real solutions. So what this means is, if we graph this quadratic, it's going to be one of the ones that doesn't cross. So something like that, where it has no zeros, no x-intercepts. The entire graph on this one, because a happens to be a +1, we know it has to open up. So the entire graph is up above. It might be here, 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 anywhere in there. Could be like that, but it doesn't cross the x-axis. So what you should see on your homework problems today is that the discriminant really does control how many solutions there are. If the discriminant is negative, you stop solving. Well, actually, you double check to make sure you didn't make a mistake. Then you stop solving and say no solutions. If the discriminant equals 0, then you keep solving and you find one solution. If the discriminant is a positive number, you keep solving and find 2 solutions. You should be able to write a summary now. Make sure that you are answering your essential question. Use complete sentences and restate that essential question as well.